to Basic Technology, Propagation, Equipment. The ability to transmit and receive radio waves is a fascinating subject. The following sequences should give you some of the fundamentals of radio communication. This should help you to understand how radio signals are propagated, short range, long range, as well as satellite communications. Radio cycles, or radio waves, are electrical magnetic waves moving very quickly through the atmosphere. One complete cycle consists of the wave starting in the reference point, such as 0 amplitude, travelling through a positive and a negative value, and returning to the original reference point 0. 6 Hz means 6 complete cycles during 1 second. Common radio frequencies start at around 15 kHz. The electromagnetic spectrum, as defined by modern science, ranges from extremely long radio waves to ultra-short cosmic rays. These are the most common marine frequencies. Typical marine frequencies are 518 kHz Navtex, 2182 kHz Voice Distress, Urgency and Safety, 2187.5 kHz MF-DSC, 156.8 MHz VHF Channel 16. Information such as speech, music, television pictures, telex and facsimile can be superimposed onto the carrier. Two methods are called amplitude modulation, AM, and frequency modulation, FM. To allow orderly radio communications without interference and non-wasteful utilization of the radio spectrum, the International Telecommunications Union decides the allocation of frequencies, power limits, and classes of emissions for specific maritime services. You will find the emissions classes in the list of coast stations and ITU manuals. Some common emission classes are A3E, AM double-side band, used for broadcasting services. F1B, used for radio telex, Navtex, DSC, MF or HF. J3E, AM single-side band, used for MF and HF telephony. F3E, used for VHF telephony. Propagation. Radio waves travel from a transmitter to a receiver in 3 ways. Ground wave. The ground wave travels near the ground for short distances, typically 80 kilometers over land and 300 kilometers over the sea. This, however, depends on a number of factors, such as operating frequency, transmitted power, type of antenna, and terrain. Typically HF communications equipment. Direct wave or space wave. The direct wave travels in a direct line from transmitter to receiver. Direct wave propagation allows communication within line of sight, typically AIS, SAT, EPIRB, Inmarsat, VHF and UHF communications equipment. These waves can travel either directly or after reflecting from Earth's surface to the troposphere surface of Earth. Hence it is also called tropospherical propagation. The other waves, like ground and sky wave, are unable to work at such higher frequencies. Sky wave. The radio wave is transmitted towards the sky and is then reflected by the ionosphere to a distant receiver. It is by this process that large distances can be achieved, typically HF equipment. Factors affecting propagation. There are many factors that affect the propagation of radio waves and the reception of a signal. Some of these are the ionosphere, sunspots, climate, atmospheric, man-made noise, signal characteristics, and terrain. Skip distance. Skip distance is the distance between the transmitter and the return of the skywave. The skip zone is the distance between the end of the ground wave and the return to Earth of the skywave. Communication in the skip zone is not possible because the skip zone can be reduced or removed completely by using the appropriate frequency. Day-night frequency choice. A frequency chosen for daytime transmission may not necessarily be a suitable frequency for nighttime use. This is because during the day, the ionosphere has many layers that absorbs the lower frequencies and reflects the higher frequencies. Low frequencies being 2 to 10 MHz, higher frequencies being above 10 MHz. At night, the ionosphere becomes thinner layered, which then reflects the lower frequencies, whilst the higher frequencies pass straight through. Seasonal variations. During summertime, increased UV radiation causes change in the ionosphere, and therefore summer HV communications usually operate on higher frequencies than those used in winter to cover the same distances. Solar cycles. Solar activity varies the amount of radiation received by the Earth and will affect HF propagation. Solar activity has an 11-year cycle, with the peak of solar activity requiring the use of higher frequencies. Solar flares can cause complete blackout of HF radio waves, though these are rare and typically last for very short periods. Atmospheric layers. Up to 4 distinct layers can be present in the ionosphere at any time. These layers are very important for the propagation. During daylight hours, the radiation of the sun produces 4 ionosphere layers. These are the D layer at about 75,000 meters, the E layer at about 100,000 meters, the F1 layer at about 225,000 meters, and the F2 layer at about 320,000 meters. At sunset, the ionospheric layers change. The D layer disappears. The E layer is at about 100,000 meters. The F layers combine into one at 250,000 meters. VHF frequencies cover only a small percentage of the frequency spectrum and are in the range of 30 MHz to 300 MHz. The VHF medium uses direct wave propagation and covers short-range communications in the range of 3 km to 5 km. This equipment basically works on the line-of-sight principle because buildings and other such high-rise obstructions decrease the effectiveness of this system. MF frequencies also cover a very small percentage of the frequency spectrum and are in the range of 300 kHz to 3 MHz. MF communications depend mainly on ground wave propagation, but with a further reduction in range due to the increased effect of attenuation by the Earth. However, skywave propagation starts to become significant at MF, particularly at night, greatly extending the range. Owing to mutual interference between stations on the same frequency, this can have a negative effect. Signals arriving at the receiver by different paths from the transmitting station can cause interference fading. Ship stations can normally expect reliable ground wave communications up to 150 nautical miles for voice communications and 300 nautical miles for DSC or telex due to less powerful transmitters and less intricate antenna systems. On the other hand, a coast station can achieve good ground wave coverage for voice communications up to 300 nautical miles, as they have very powerful transmitters and complex antenna systems. HF frequencies also cover only a small percentage of the frequency spectrum and are in the range of 3 MHz to 30 MHz. Skywave, a system designed to communicate over long distances, normally anywhere between 100 and 3,000 kilometers, when used with an antenna designed to radiate with a high angle of elevation towards the atmosphere for the signal to be reflected back by the ionosphere to the receiving station. Ground wave. The HF radio can also be effectively used for shorter range communications, that is, from 0 to 100 kilometers if a correct antenna is used to propagate the signal horizontally along the ground. Skip zone. There is a skip zone after approximately 100 kilometers, which is more or less the extent a ground wave will travel, to the point where the sky wave is reflected back to Earth. This distance is totally dependent on the frequency used. The skip zone is an area where communications is not possible, although it can be reduced or completely removed by the use of the correct frequency. When selecting an HF band for a particular range, the one most important piece of advice is to select a higher frequency in the band by day and a lower frequency during the night. If your call is between day and night zones, 12 MHz is a good alternative. A HF SSB transceiver is simply a high-frequency transmitter and receiver in the same package. SSB, single-side band, is a term used to describe the method of compressing the transmitted information, voice or data, into a more compact signal. The propagation path used by HF signals from the SSB radio transceiver to achieve long-range communications is the skywave. If your call is between day and night zones, 12 MHz is a good alternative. Satellite daytime. You transmit a radio call via satellite for long-range communications. We're talking about transcontinental traffic from one ocean to another via satellite. Satellite nighttime. You transmit your radio call successfully, long-range communications, while using the same frequencies at nighttime. This bridge is equipped according to Gmdss. In the following, you will receive guidance through a typical setup. The VHF radio is used for short-range radio communications to other ships or to shore. On the VHF channel 16, the radio signal takes the direct wave, line-of-sight propagation path. Digital Selective Calling, DSC, is an automatic calling system for terrestrial radio communications. Ships can transmit distress alerts containing the most important fact about the distress, the identity of the ship and its position. This goes very quickly as the DSC is connected to the different nautical systems on the bridge, such as GPS. Subsequent communication will then follow on radio telephony. This is an MF-HF radio system. This is an MF-HF radio system with the DSC system. Fleet 77 is a multi-layered priority system that allows distress, urgency and safety calls to take precedence over non-essential and low-priority regular communications. This control panel gives you information about the satellite, and you can switch between satellites. For example, select one when you are in the Atlantic Ocean. The Inmarsat Fleet 77 system is a real-time online system used for global voice, fax and data communications. The antenna is small and should be installed in order to ensure that it will stay in line of sight with the satellite. It is important to mention here that the Inmarsat system communicates through space wave, which requires that both the transmitter and receiver stations remain in direct line of sight. The transceiver interfaces a computer to the satellite systems. This transceiver contains the transmitter and the receiver to ensure safe communication via satellite to the Coast Earth Station. The EPIRB should automatically float free at a maximum depth of 4 meters. It should then be automatically activated. You can activate and deactivate the EPIRB by yourself as well. The batteries should keep the EPIRB activated for at least 48 hours. This is a SART, Search and Rescue Transponder. The range of the SART depends on where you have been able to put it on your life raft and the height of transmitting radar antenna on the rescue ships. Try to get your SART up at least 1 meters above the sea level, then the range will be 5 nautical miles. Via this Navtex you will receive maritime safety information, MSI, as nautical and meteorological warnings. Certain groups of coast stations transmit in MF frequency 518 kHz on a time-sharing basis. Coast stations may use 490 kHz for transmissions in national languages. 4209.5 kHz is also used for Navtex transmissions using telex onboard ships. And finally, the power supply sources on board. If the main source of electrical power suddenly fails, the accumulator provides power for at least 1 hour to your radio systems, and the emergency source will take over when it is ready. All this should be done automatically. The emergency generator should be able to last for at least 18 hours. Operation of VHF radio, VHF DSC, MF HF radio, MF HF DSC, Inmarsat Fleet 77, EPIRB, SART and Portable VHF, Navtex. This is a VHF radio telephone. Point the cursor to the buttons on the VHF to get information about their functions. Mayday, Mayday, Mayday. This is Sierra Lima Charlie Echo, Sierra Lima Charlie Echo, Sierra Lima Charlie Echo. Position 50 degrees north, 000 degrees 54.3 minutes west. We have had a collision and are sinking. We need immediate assistance to abandon ship. 20 men on board. Good visibility, calm sea. This is Sierra Lima Charlie Echo, over. Point the cursor to the buttons on the VHF DSC to get information about their functions. A DSC distress alert consists of the ship's identity, MMSI number, nature of distress, the ship's last known position, the time the position was valid, and the type of subsequent communication. When the DSC equipment is connected to GPS, the ship's position is automatically updated. Otherwise, the ship's position must be updated manually every 4 hours. Undesignated distress alert. A distress alert can be transmitted at any time by lifting the lid and pressing the distress button for 5 seconds. The nature of distress will be undesignated. Content of undesignated alerts. Ship's identity, MMSI number. Nature of distress, undesignated. Position. The position from the GPS or the manually inserted values. Time. The time the position was valid. Type of communication, telephony. The distress alert will be sent on channel 70. The call attempt is automatically repeated after a random delay of between 3.5 to 4.5 minutes. The automatic repetition of the distress call attempt is terminated automatically on receipt of a DSC distress acknowledgement. This is an MF-HF radio. Point the cursor to the buttons of the MF-HF to get information about their functions. Mayday, Mayday, Mayday. This is Sierra Lima Charlie Echo, Sierra Lima Charlie Echo, Sierra Lima Charlie Echo. Position 50 degrees north, 000 degrees 54.3 minutes west. We have had a collision and are sinking. We need immediate assistance to abandon ship. 20 men on board. Good visibility, calm sea. This is Sierra Lima Charlie Echo, over. Point the cursor to the buttons on the MF-HF to get information about their functions. A DSC distress alert consists of the ship's identity, MMSI number, nature of distress, distress alert frequency, the ship's last known position, the time the position was valid, and type of subsequent communication, by radio telex or radio telephone. When the DSC equipment is connected to a GPS, the ship's position is automatically updated. Otherwise, the ship's position must be updated manually every 4 hours. A distress alert can be transmitted at any time by lifting the lid and pressing the distress button for 5 seconds. The nature of the distress will be undesignated. Content of undesignated distress alerts. Ship's identity, MMSI number. Nature of distress, undesignated. Distress frequency. Position, the position from the GPS or the manually inserted values. Time, the time the position was valid. Type of communication, telephony. The distress alert will be sent on 2187.5 kHz. The distress call attempt is transmitted on the selected DSC distress frequency or frequencies. Information that the announcement has been transmitted and the message will be sent. Rescue Centre UK. Go ahead. You have initiated a telephony distress call to your default land Earth station. In this case, it is Goonhilly in the UK. Inform the land Earth station about your distress. LES operators and Inmarsat terminal manufacturers normally refer to the 2-digit codes that are designated for maritime safety and general services as Special Access Codes, or Short Access Codes, or SACS. The following 2-digit codes are defined for maritime safety services. 32. Request for medical advice. 38. Request for medical assistance. 39. Request for maritime search and rescue assistance. 41. Sending meteorological report to Met centres. 42. Navigational hazards and warnings. 43. Sending ship position report to shore authorities. On your telefax terminal keyboard, there are 4 special buttons. Click on these buttons to learn more about them. This chapter describes 3 types of raft equipment. You will learn their controls and how to operate them. Select any of the equipment to the right. Point the cursor over the different parts to learn about their functions. The EPIRB floats free if the ship sinks. It is activated automatically when exposed to water. The EPIRB should, when possible, be attached to the life raft with a line. Point the cursor over the different parts to learn about their functions. Remember to bring the SART with you into the survival craft. Mount the SART at least 1 metre above sea level. Navtex is a coastal system for automatic broadcasting of maritime safety information, MSI. Point the cursor over the different parts to learn about their functions. First, you need to set up the C area where you operate. Press the menu button on the panel above.